All right, welcome to class and online on this chilly morning. For this, we're going to start Unit 2 today, which is really Unit 2 is really on again data cleaning and organizing data, preparing your data for this. Um, I it's hard in this course to decide what to cover here. There's lots of new topics in machine learning. And so I keep cutting out things early into things so we can cover new, more complicated machine learning topics. And I've almost cut this, but the problem is that my experience is that more machine learning projects fail because of bad data and non-clean data and stuff like that than because of model training or other things there. And that this is often overlooked and actually causes some really significant problems in machine learning and any sort of data analysis here. I mean, we have a separate class in data visualization. I think there should almost be a separate class just in data manipulation, data cleaning, and that sort of stuff. And maybe if you're in like the data analytics concentration, you do some of the other data analysis classes, they'll go into this some more. But I think it sometimes falls through the cracks. So that's why we're largely spending this week. And it also gets us started on using more Python and just looking at data and visualizing data and stuff like that. We will be doing some data visualization this class and talking about it. Who has anyone taken or is anyone taking the Chris Church's data visualization class? Are you in it or have you taken it? You're in it now? Right, okay. So I mean, that's a great class. Chris does a great job. And again, that's using Tableau, our software, just for data visualization there. So yeah. Machine learning, yep, that's here. Do you have a login yet on the computer and stuff like that? Your Brightspace is okay. Well, why don't you sit down? You might not find a computer and stuff, and we'll see if we can get you going in a little bit. Okay, yeah. So, okay. Sorry for that quick interruption. So again, the data visualization will be doing that. And a lot of what we're doing here is visualizing as part of data analysis so that we can see if the data is good or not. Not necessarily data visualization for a client or something like that. Sometimes we just need to explore the data, get to know the data, so we can help identify outliers, identify issues with the data, to prepare it for our machine learning. So we're going to do some visualization here, but again, and some of it's kind of cool, but again, it's not meant to replace the dashboards and the really nice visualizations we get in the data visualization class. So I'm going to go to Unit 2, and we've got two things. We're going to talk about correlations or regressions second. So we're going to start here with the data cleaning stuff here. I'm just going to link, and I'm going to start with this to talk about a couple of these articles here, the data cleaning and machine learning. Go through this. This kind of just is an okay overview of data cleaning. What you'll often hear is the term garbage in, garbage out, meaning if we have garbage data, we have bad data, we get bad models. If we get good data, we get good results, sort of idea. And that's what they're talking about. Better data is better than fancier algorithms. If you can clean, more things fail because of bad data than any sort of issues with the algorithms themselves generally. So better data beats cleaner data stuff here. So we're going to talk about different things we can do. First, we're going to want to remove unwanted observations. It's kind of a weird way of saying this. And one of the things we actually will talk a fair amount is issues with bias in our data. And it is very common in machine learning to have biased data, and the machine learning models are very good at reflecting that. So it's very easy to create biased models that are very biased for one area of it, depending on how where the data comes from. There were for many years, like face recognition systems were trained by companies that were largely white males, and so most of the photos they trained them on were white males, and so there were issues with that. We'll talk even about breast cancer data here, and where are we collecting that breast cancer data from, and is there bias in that? So when we say remove unwanted observations, that's not what we're talking about. We're not talking about bias. The process of working with bias and trying to get data from proper sources is a whole separate here. This is saying we collected some data, but there are some observations that we don't want here. So they're often duplicate or irrelevant. And the one we're going to focus on the most is duplicate collections. So these duplicate observations here, where again, we'll have multiple records of the same thing. And often this comes from we're doing SQL queries on a database, and you'll have multiple entries. I don't know if you ever get this, but it is not uncommon. It's getting better these days, but used to be, I would get, or my household would get 2 or 3 junk mail or mail from the same organization to the same address, but with slightly different names on it. So I would get, some some company would send me out, and it would be one to my address at Tom Gibbons at my address. Another one would be Thomas Gibbons at my address, and maybe another one. So, this company obviously had 3 copies of my exact same address with slight variations in it. So one might write out street, and the other one might have ST in it or something like that. They're all slightly different, but they were all the same. So again, when we say duplicate observations, they might not be exactly the same, but they might be, talk about the same person or relate to the same underlying data for this. So that's something we have to look at for this. How do we handle the duplicate observations here? And again, there are ways to search the data. Often what we're trying to do is maybe tie it to an address or a fixed point, a known point of reference there, like a phone number or a customer ID where everyone has that same customer ID, or something where we can narrow it down, eliminate some of these duplicate values here. Irrelevant observations, sometimes you're collecting data and you just get data in here that doesn't fit. Sometimes you're doing a query to a database and you're getting more data back than you want here. So I'll sometimes go to our database and I'll do a query of records, and I'll want, just give me the students who are computer majors. I'll get this back, and I won't notice things like, oh, it's not getting current student, it's getting every student for the last 20 years who's a computer major. And that's not what I want. I only want current students there. So sometimes when I write queries or grab data, I'm grabbing it and not refining it down correctly there. So next, let's talk about fixing what they're calling structural errors here. So this is a nice graph trying to show what people put on their roof here, and they've interviewed people and asked them to give their results here, and they have this nice chart of this. But there's some issues with this. One thing is they're not maybe 15 different things you can put on your roof. There's only maybe 5 there, and so we have lots of duplicate or things like that. What we see here is here, composition shingles and composition singles, one with a capital C and one with a lowercase c. Those are the same thing, right? They should be grouped there. So both composition and composition refer to the same thing. Similarly, like asphalt shingles here, they have this asphalt with a capital A and this asphalt with a lower a. Those should be the same there. And so often just with the data collection, maybe, how did they collect this data where they would have gotten that? So obviously it wasn't somewhere where people just selected one of an option with like radio buttons or something like that, or a pull down menu. They had to type in these values because some people typed it in with a capital and some people typed it in with a lowercase here. So we've got to check what we're doing as far as this data and how we're collecting this, and do we need to combine it? So like the shakes shingles with a dash, shakes shingles without a dash, but with capital letters here. And some of these are like asphalt shake shingles. Should that be asphalt or should it be shake shingles for that? How should we group those together? This is actually a really big problem in data analysis. There's a company just outside of Duluth named Imagi Research. And they actually, their whole company is around going through medical data and clearing up errors like this in the data for this. One of the things, what they work on a lot is that hospitals will have their, patient visits, all their patient data, all their insurance data, and they'll submit it to the government like Medicare or Medicaid for reimbursement. And the government will go through the data and will find errors or will not recognize certain values here for it. And a lot of times it's like, oh, you've got a patient with this name in this file, but then on the exam record, it's a different name, slightly different name, and they don't match exactly right. And so we can't find this. Or you're saying the symptom, but it doesn't match the symptom that's, and again, if you're familiar with health informatics, is the whole coding method and stuff, and how we code records here, and how we code procedures. And again, sometimes the way those are coded is not correct. This whole company, all they do is they'll go through your data and clean it out and resubmit it to the government to correct those data, and they'll just take a small cut of that cleaned up data, or of the new revenue that's generated from cleaning up the data. So that's all they're doing, is that sort of stuff. Okay, so they're doing stuff like this. I remember at one point talking to them years ago about their SQLs, all the SQLs they write that will replace everything with this capital letter with this lowercase version of it and stuff like that. So, another thing we have to watch out for is mislabeled classes. A lot of times we'll see terms like N/A are not applicable in our records. And we'll see in a little bit not a number, NaN here. So depending on how the data was collected, if people did not fill in values, we'll see different options for that. And the question is, if someone didn't answer a question, how, or they're missing values, how do we manage those? And we'll talk about that in the next document a little bit more. So, how about outliers? We want to filter out unwanted outliers here for this. Oh yeah, here we're talking about first missing data. Well, let's talk about outliers. When is something really an outlier? And that's something you're going to have to deal with the project this week. You'll be looking at values, and you want to there'll be some outliers and some other data that's just strange, I guess. So the question is when you're looking at data and do now, how much statistics have you had like in high school and stuff like that? So you know what an average is. You have a whole set of numbers. You know how to calculate the mean or the average of it. How about standard deviation? Have you heard of standard and familiar with standard deviation there? So, that's a measure. If we say something's one standard deviation away from the mean or the average, then it's kind of in this bell-shaped curve for this. Uh, Most data is within 3 standard deviations of the mean there, assuming normal distribution. So there's some assumptions there that don't always apply to our data there, but a lot of data is there. And so sometimes we'll talk about this one on Thursday more. How do we identify an outlier, and can we just use standard deviations? One of the problems we have with outliers is, are they actual outliers that we want included? Like, we'll be looking at breast cancer data and the size of a tumor or the concavity of a tumor there. And so someone's going through and measuring that and entering it in on the computer there. Some people might just have strange tumors there. There might just be, I mean, this might be just a 1 in 100 value or 1 in 1,000 value there. And if so, maybe we want it in our data because we want our data to, we don't want, if you're just that 1 in 1,000 person, we don't want you to just get misdiagnosed for cancer there. But sometimes outliers are just from when you're entering the data, data entry error or something like that. So maybe, rather than saying 47, you hit negative 47. So, sometimes the outliers are very obvious that this could not be the case there. So if you have a tumor inside a breast cancer tumor and it is, 4 meters across, well, there's no way you can have I'm not 4 meters across. I can't have a 4-meter tumor inside me. That's not going to work there. So again, we've got to try to look at when is something, really an outlier, meaning it's a mistake and shouldn't be in our data. And when is it just, oh, that's a big tumor there, but that's probably still legitimate. It's not 4 meters. Maybe it's 4 centimeters or 4 millimeters or something like that. Okay, so that's the outliers. Missing data, we talked a little bit about this, not NA, not applicable, or not or N/A. You also see issues where sometimes we'll see not a number or something like that in values here. What can you do when you're missing data here? So what should be done? Like, we just had elections this year. When you're filling out a ballot and let's say you don't vote for someone, what should happen to your ballot when we don't vote for everyone? Should we just throw out that ballot? No, we keep that ballot, right? We just process all the other. We just, kind of ignore the fact that you didn't vote for this one part of this election. And that's kind of what we're looking at with missing data. There are times where we will just drop out the missing, the whole row. Like if, let's say people are taking this survey and someone didn't answer all the questions, we'll just maybe, the easiest way is just to get that person out of the survey there. But sometimes, there are many reasons why we don't want to do that. But then how do we handle these missing observations here? Are there other ways of handling these? So sometimes to like calculate average, we need values in every spot. Sometimes our calculations that require numbers in every value there. So there are the ways where we cannot do that. Can we put in a 0 there or some other value? Can we just fill it in with the average for that field? What do we do to handle these missing values here? So there are different ways we can do this sort of stuff, and kind of depends a lot on the data for that. So, okay, I'm going to jump to this other one here. Okay. Um, Again, this talks about this garbage in, garbage out sort of process again here, and data quality. I like this sort of stuff. They talk about a couple measurements of data quality here. Validity, how valid the data is. Does it uh, conform to our business? Does it fit our requirements for this problem here? Accuracy is how well it was collected and measured. Are they true values for this? How was the collection process done? And that completeness, again, did we, where is there bias? Are we missing populations in our data? Are there places where we didn't get this data from for this? Also, kind of related to this, I think, is that are there some populations that are oversampled and some populations that are undersampled, or how complete is our data for this sort of stuff? We can talk about consistency. Again, we're looking at where the data was collected and who did this. Sometimes you'll find like if you're doing collecting data with interviews or with something like that, you'll see things like certain people will do certain interviews and some people will get different results than others from an interview or some sort of survey or something like that for this. So how is the data collected there? I've seen places where, again, we'll talk about flowers and the size of the petals. If you just ask people to measure the size of petals without any training, or the size of flowers, some people just always measure them a certain way, and other person measure a slightly different way. And so you'll see inconsistencies in the data, where to get consistent data, you really have to train your flower measurers, how to hold the ruler, where to measure. You measure this part of the flower, this part of the flower. Where are you collecting this data for this? So sometimes consistency requires that you train the people who are collecting the data in how to do this. So in uniformity, again, we're just talking about a cancer tumor that's 4 meters across rather than 4 millimeters across. So are we using the same units? How this works? I actually run into this really common problem with like international data, where the date format is often wrong because Americans like to specify month, day, or year, and Europeans will flip the month and the day around. And so I'll see a date like 4/8/2025. And so if you hear 4/8/2025, is that April 8th or is that August 4th? Which month day combination it is. So that's just, again, uniformity in the data collection. They're talking about pounds and kilograms here also. So, okay, so often we'll look at some sort of data profiling. We'll look at some summary statistics. When we go through this, we'll do some visualization, help us see the data, identify outliers for this stuff. There are packages that can help us do some of this. Then we'll go through some cleaning, removing some irrelevant data, removing some duplicates. We often have to look at the type this is. In computing, we can store like a number like 47 as an integer, but we can also store it as a string, quote 47. And so in a computer world, the type is just a string or a number varies, can affect how the data can be analyzed for this. So, okay, I'm gonna go back here. Let's talk a little bit about visualization here. And then we're going to look at this example here, Unit 2, Data Cleaning and Visualization Notebook. So we'll look at that in just a second and work through those examples. Um, in Python, there are too many ways to visualize the data. There are actually three main libraries. Pandas has a plot command that is kind of the default here. It's really simple, but a lot of places use it. Here you can just say, you have some data in what we call a data frame, you can just say plot and draw out different types of graph with this. Um, a lot of people use a little more complicated library and bring in something called matplotlib here. This is a more complicated library that generates a little better graphics here. So in order to use it, we have to use what is called an import command to import this library, and we give it some name like PLT, and then we'll do like PLT dot, and we'll create up plots with subplots, and we'll see examples of that. On the last one is something called Seaborn, is a nice aesthetically pleasing kind of idea. These visualizations look very nice and cool sort of stuff. So you'll see this sort of visualization is Seaborn sort of stuff. Nice use of colors and more sophisticated graphics and stuff like that. Now, why is it important? Well, the easiest one, this plot, a lot of people use because it's just so simple to use. But sometimes you want to use some more complicated stuff. Why is it important for you to tell differences? That often when like in the project or assignment, you'll be working on a graph and it'll give you an error. You say, oh, it's some syntax there. So you ask AI to fix that error. If you can tell AI which library you're using, or if you're searching on the internet for the answer directly, if you know what library you're working on, that'll help you a lot to get better information or better results from AI. So if something's not working or you want to change something, if you just say, oh, I'm working on a Seaborn graph and it's giving me this problem, or a matplotlib graph, the two answers will be quite different depending on if you're using this library or that library. So just know that there are three different main libraries, and we'll try to talk a little bit about, we'll see how they kind of vary a lot. Okay. So I want you to open up this Unit 2 data cleaning example. So again, I'm going into, I'm in Unit 2. I'm in the cleaning and visualization of the data. Scroll down to the very bottom, and it's this Unit 2 data cleaning visualization notebook. Open that up here. And we'll walk through this stuff. So we're going to look at the same sort of cleaning data and visualizing it. Three things. We'll do a really quick survey today of this and get you kind of started on it. On Thursday, then we'll go through basically the same material, same sort of ideas again in our iris flower data in the notebook for that. And we'll go over it again. And then for the project this week, project 1 and 2, breast cancer analysis and visualization, you'll do the same sort of stuff. So the idea is that we'll do this, kind of see this 3 times and see it 3 different ways. So this is kind of our just first introduction to this. So again, this is a notebook here. I'm just going to go through and run these cells as I do. So here's our first set of code where we're importing our libraries. So we import Panda and NumPy for handling our data. But for visualization, we're also importing Seaborn as SNS. So anytime I see SNS in a graph or something like that in a command, that's going to be Seaborn. I don't know why they use SNS for seaborn. I never quite understood that, but that's really common out there. And matplotlib is just going to be PLT. So again, you can actually change these things, but I'm going to leave them here because these are standard. A lot of people use them and use this abbreviation for them. So those are our libraries. So we've imported our libraries. Now we're going to bring in our data here. This data actually comes from this data survey from Kaggle on what tools. So there's this code out there. And again, they did a survey of a bunch of people and what tools and what languages they are using in their data science stuff. So that's what this data comes from. Okay, so I'm creating a data frame with this data here. I'm not actually bringing it from, I just have it. Now, I've actually put some errors in this data that we'll see what it'll try to process. So, for example, the number of respondents is 165, 195. One of them is minus 999, and another is not a number value. So we'll see that. So I've introduced some errors into this data so that we can, artificially, so we can do that. So this is messy, messy data that we have in here. Now we can start looking. How do we want to look at this data for this? One thing I'll just tell you is that, one thing you can do is like, if this were if it were just this way, I would just open this up in like a spreadsheet and look at the data in a spreadsheet. Just on a screen, you could see all the data here. And that, if you're just looking at 100 records, you can just open it up on a spreadsheet or something like that and look at it. It's not hard. There you can just look through and sort and do that sort of stuff. But a lot of times our data will have 1 million records in it, and you can't very easily open up. Well, I don't know if you notice, there are limits to how much data you can open up in a spreadsheet. There are a maximum number of rows and columns, and I've hit those row maxes a lot here. So although we're working with just a small amount of data in these examples, we're giving you tools that'll work with huge data sets. If there are 1 million records here, these rules will still work. So that's why company will ask, well, why are you using things like had here when you could just show all the data for that? So that's why. So again, one thing you just have to know is, what is our data variable? Every time we work this, we'll have some variable for our data. And in this course, in this example, it's the first language the users use. What was the first language used for data analysis? So there's a variable called first lang, and it's a data frame. And again, that sets this up. So all we have to know is that first language is our variable. So we can say that first lang dot head and specify 5 to show us the top 5 languages here. Now, if I only wanted 3, I could say first lang had 3, and run that, and it would show me only the first 3 languages here. If I wanted the first 10 languages, I could say had 10. So I can display this. And again, a lot of times it's just the had, using a command like this lets you just see how this works. Generally, our data will be set up in kind of tables like this, where we'll have columns. Each attribute will be a different column. So the first attribute here is the language. The second column is the number of respondents, and then who use that as their first language. And the third one is the percent of them that use this. So this is set up that way. And then each one of these is a different entry. So like here, each one of these is a different language. So each row is a different record or value kind of here in our values. And it's very common, like here we have an entry for each language. You could also have like surveys where every person is a separate row for this stuff. So here you can try some other examples of had 10. You can just say first language. So again, one thing where you want to practice here is commenting and uncommenting lines. So if I run this, what is being run here? Well, anything that has a comment and is green is being ignored. So all these commands are being ignored here. So the only thing here is this first lang dot tail parentheses 5. So tail will be the last records in our table and the last 5 records. If I want to do something else, I could comment that out, put a pound sign in that, and uncomment something else. So I could just say first lang. What if I just listed the variable? How does that display? So I'll display the whole table here. What if I tried to do a print command? And again, I generally will just comment out everything except for the one command I might want to do. So if I say print first lang, it prints it out kind of as a table here. So you can try out these different commands and see what they do. Now, often with these sort of data, we're going to want to slice and dice them, is what I say. So we want to maybe grab certain columns and certain rows. Again, sometimes we'll want to get rid of, like maybe this row. We'll want to cut this row out here. Have you ever? I've never played. I've seen people play the game like it's a VR game. My daughter has a VR headset where I think it's fruit that flies at you, and you have to hit the fruit in different ways. So that's, I always be like that. I wish we could do that. We should have this data flying at us, and we should be able to chop it up in the, get rid of the bad fruit or the bad values here. So that's what we're going to try to look at. So and first we just have to do, well, how do we slice and dice? So how do we select a column or two from the data frame? So there's different ways of doing this. So here's our data language. Each column has a different label at the top. So I can just say first language dot respondents, and that will just list the respondents column. So it's basically just grabbing this one column out of our data. And there's different ways of doing that. One thing you'll find in Python is there's often 10 ways of doing the same exact thing. So I can say first language bracket quotes respondent, and that does the same thing here. If I want to do a couple language or a couple columns, I can do, and again, I'm just commenting out some of these and uncommenting others. I can say first language, and this is kind of weird. Here, this made sense to me. I just have a square brackets and respondents in between. If I want to list more than one, I have to do double brackets. It's kind of weird. I do a bracket, square bracket, and another square bracket, and then that's my list of items. And then I end. So basically, this, I put a list in here, and the list has square brackets around it. And that has to go into my other square brackets. Now, if you're new to Python, new to programming, this is an area where you could use AI a lot for things in different ways. So you can, so there's a couple things. You can just have AI in another session. So maybe we have ChatGPT running, and I'd ask it, and again, part of this is just knowing the language here and getting used to it. So what am I trying to do here? So if I look at this command, I'm trying to like have a table here. So I could say how do I select columns in a table? Well, AI is not going to know if this is an Excel table that you're asking about or Python or whatever. So I often want to say I'm in Python. So I could say, how do I select one column in data in Python? So I could ask something like that. Um, it would be better. I'll get even better results if I say things like I'm using I'm if I see this is PD, and if I look at my libraries, PD is pandas, and I'm using a pandas data frame, and that's what we'll use a lot. So I could just say a panda data frame, or I could say, how do I select one column of data? And I say from a data frame, because there are other ways, data structures in Python. They can do it, and hopefully it'll show me. So they're showing this the DF. Now, if I were to try to take this and paste this in here, let's add let's see, add some code here, and I'm going to try to type that in. Oops, I'm going to add that code, not there. Sorry. I'm going to go down here and add that code. So if I put that code in here and run it, it's going to give an 8, DF not defined and stuff like that. So working with this, I might want to provide even more things. So like I could say, and maybe I'll just say, okay, I am getting an error. My data variable or data frame is named first language, and I want to get the respondents column from it. So I can ask a little more detailed data specifying what variables I have and things like that for this. Oops, I'm asking really smart. So, okay. So this is saying easy way, it tells you how to specify how, what are the columns named, and make sure you can do that. So it says maybe go in and just do that first. So I'm going to say print first language dot columns. It'll tell me what the columns are, because it realized that I probably misspelled the column name there. And then it can say, now you can use your data frame dot stuff. So like here, you can try this first language dot respondents. So I could try that here. And again, I can even take the exact column name here and paste that in here. So again, asking AI is helpful here, but again, sometimes you have to walk AI through this. Now, one nice feature of this is that we have Gemini built in here for this. And there are some commands. So now I can actually add, I could go back to maybe my original query, and it might be better at that because it will know what data I have here. So it's doing their own thing, adding it. So how would I do this with the first lang data here? Let's see if it can see the data in my column. So again, it says, assuming you've already set up your data like this, here's what you can do to it. So again, this Gemini here, by clicking here, will know more about your data and stuff. Might be a little easier to work with than other. You can use other AI, but you might have to provide more background with other AI when you're working on this. Okay, so that's how we can select columns. As far as selecting rows or columns, there's a special command called iLocation, individual location, ILOC. And again, we can select things. So we can say, I want the second through the fourth row. So if I just specify one value, it's what rows to get. and I get all the columns. If I want to get certain column, or certain rows and certain columns, I can specify this. I want rows 2 through 5 and columns 1 through 3 here for this. Now, when I say rows 2 through 5, computers treat that as starting at 2 and ending before 5. So that'll get me 2, 3, 4. It won't get me 5. And same with columns 1 through 3. That means columns starting at 1 and stopping before we get to 3 here. So that's columns 1 and 2. Now, if we just want certain columns and not in all the rows, we use this sort of command here, where we would write iloc, and then this colon here, or no, the comma, on the left side of the comma are the rows, and the right side is the columns. And so if I want all the rows, I can just have a generic colon there, and then certain rows, oh wait, no, this is rows, this is columns, certain columns I put here. I never remember how the iloc command works. Every single time I use it, I have to ask AI how to use it. I can't, even right now, I cannot remember which, is it rows first and then columns? Where's the colon? Where's the comma there? I always have to, but I know there's this iloc command that does this, and that helps. You can just ask AI how to do this. And unfortunately with Python, there are like 10 different ways to do rows and columns. I like the iloc the best. I find it makes the most sense. So I like that. So I always ask it, using iloc, how do I select, I want these rows and these columns, and AI or Google will help me figure that out for this. So just so you know. As far as the data format goes, we can look at a couple things like how the whole data is. One thing we can look at is the shape of the data. We can say first language shapes, and I'll just tell me how many rows and columns. There are 9 rows and 3 columns, which is helpful sometimes. We can count how many values there are. So this says there are 9 values in the language column, 8 values in the respondents column, and 9 values in the present column. And what this is telling me is that there are some empties there. So it might be not a number or blank values here. So there are some places where if this were a normal table where all the fields were filled in, like this should be all 999. Every column should have the same number of values in it. But this one is saying respondents here. These are numbers, but they have one bad, not a number in here. That's giving up problems. So you can also just ask, you can say first language.info parentheses here, and it will help you tell you about that. So there are 3 total columns. Each of the columns, it also tells you how these are formatted. And again, if you know computer stuff, you recognize some of these as, oh, this is a floating point, a decimal number, or this is an integer, or this is a string like object here. We're not going to worry too much about that. I will generally set this up so that all the columns are in the right format, at least for you. Okay. So let's say we want that. Now we want to remove some null values here for this. For example, here, this had this not a number value here. I'm going to delete that possibly. So there's a command I could say called drop NAs. Drop like not a number, not a values, these special fields that hold, non legal values. So you can always say your variable dot drop NA here. Now you can put this on a line by itself. I can say drop NAs, and it'll run and it'll show me the values with that dropped but it doesn't update the variable this way. It just creates a new copy of the data with the values dropped. So what we often want to do is save that somewhere. So I'm saying first language dot drop NA. I'm going to save that in a variable called first language underscores clean. Now, if I run that, it's not going to display it here. But if I look at that, or if let's just display that. If I just say, so here, if I just display first language, that has the blanks in it. But if I display first language dot clean, that doesn't have the blanks in it for this. So again, sometimes when we do commands, they're not going to change the underlying data. They're going to make a new copy of the data. So I should save that. I can save that into the new variable. So a lot of examples online will save it over. If you want to save it over the old one, you don't need the original data. You can say first language equals first language dot drop NA. So that'll overwrite the first language data with a version where all the NAs are dropped. I prefer to keep the original data around and make a cleaned variable or a variable that holds the clean version of that. So again, on Tuesday, we'll be going through and doing this. Tuesday, you'll have to find very large and very small values to drop them out. So there's, again, a way to find the largest. Here you can say your variable. And again, now I'm using first language underscore clean, the cleaned up version of this, dot n largest. And I say I want the 3 largest. And what field? I want to look at the respondents field. And we'll sort and display those. And smallest will display the smallest ones. And again, this is good at looking at, is there an error in this sort of stuff? So, this seems really large compared to this, but is that accurate or not? It doesn't seem that. I mean, it's 10 times larger, but is that okay? Now this, that's actually a legitimate, that's actually the results here. But like this one, the -999, that's obviously an error. So I'll want to get rid of that one here. So one thing I can do is I can say I want to get rid of, like, I only want the records where the respondents is less than 0, or only want the records where it's greater. So this will just give me the ones where this one field is less than 0. I can also say I want everything, but it has to be above 0 for this, and they'll give me the data removing all the negative values. So, and again, we talk about some ways of removing and adding data in here. Last thing we'll talk about here is some visualization stuff of this. We'll walk through some of this. So we're going to set up our data again. Now this is a cleaner version of the data here. So first language is now a cleaned up version. So we're because I want the graphs to work here. Let's just show some things. Here's well, actually, I don't need to run this. This is the plot command. If you say like your variable first language dot plot here, this will just generate, it usually just generates a line graph or something like that of the thing. And plot is just the panda plot command for it. And again, you can do some tweaks to it, but it doesn't have a lot of functionality. So you can say like dot plot dot bar instead of dot plot here. We'll switch it to a bar graph, but and then you can say which column do you want to plot. So I want X, the language on the X-axis, and the respondents on the Y-axis to do that, and it'll plot that. So again, plot can do some basic things. We mentioned matplotlib. And again, here you'll see the import. generally you don't, you just have to import once. So that's at the beginning. And again, here we can create this. So again, it's plt dot bar, and then we specify our variable here, the X and the Y, the language and the respondents here to get this plot. You can also do this sort of pie chart, plt.pie, and again, you can specify how this works. We're not going to be able to do Seaborn right here because Seaborn needs more data to actually do any of its useful plots. So we'll look at that on Thursday. We'll look at some Seaborn sort of stuff. Actually, I think here, oh, we're bringing in the actual survey results here with all the details. Okay, and here, now we're getting plots of that. So this is just our normal Python plot command. This is Seaborn here. So we're importing Seaborn here. And again, Seaborn commands are often split among multiple lines. So we're maybe setting the size of the figure, setting what we're trying to plot here, what data we're trying to do, and then like rotations and stuff like that. I'm not going to teach you much about using Seaborn. There's so many alternatives here. There's tutorials here. AI can help you with this. What we will be doing is kind of playing with this stuff. So taking a current plot sort of stuff and changing it here. So like rather than plotting this column, we'll change it to a different column here. We'll look at different columns. Maybe this size, we'll change it to a different size and stuff like that. So generally, we'll want you to modify some existing Seaborn plot or graphing to be different data or different setups for this. You can get some nice complicated graphs. And one of the things we'll want you to kind of try to understand is, what is this graph like? What is a graph like this trying to show for this? So like this is trying to show, this just shows, let's see which one. This is different job titles here and how many people had these different job titles. So this many people had the software engineer. This people were listed as data scientists. This many people were a student. But again, that's just the total number. You don't see necessarily how that works or how that ties into maybe their degree that they got or their salary. So this is showing a map of salary to job title. So different salaries. So each of these are different job title, and this side over here is the salary. But we also see the individual plots, but we also see some plots we see the median value here. We see 1 deviation away. We see 3 standard deviations away, and then we see outliers for this sort of stuff. So it's a different sort of plot it's trying to convey. So one of the things we'll try to look at is what. So sometimes, I think this has some interesting, I see some information in this data, but you can also generate plots where this one, I don't know if this shows, this is age versus salary estimates here. So maybe it's showing that there isn't a lot of change, that I'm not seeing a trend where as people get older, they'd be earning more money in this data. So, okay, we'll do more with that on Thursday and look at that. And again, your job this week will be doing some visualization. So the project is tied around visualization. Also, for your discussion thread, we want you to look at some good or bad visualization examples out of there. So there are some places to look for visualizations, and you want you to pick some and do it. Reddit has their R data is beautiful postings here, and you can see different values. Now, let's see, it's set to top postings this year. Switch it to this month. How about? So again, they'll show some apps like this is a experience as a hiring manager hiring people and how many people applied and where they dropped out and how many they actually hired. So there's different visualizations here, different ways that you can look at. So your job will be to find, as part of the discussion, find a visualization, post a link to it, and talk about how you liked it or not for that. So that'll be part of your discussion. And then for your project, one of the main tasks will be to do visualizations and talk about, you'll have to create 5 visualizations for those. And we'll talk about that more on Tuesday. No, today's Thursday. Okay. We're going to spend a little more time today talking about correlations and regressions here. So I'm going to go here. We used to have a whole separate unit on this, and I've gotten rid of it. So I'm going to cover that whole unit in about 15, 20 minutes, because I actually think you know most of this already there. So you probably know what a correlation is already for this. So I'll just highlight. So when one thing is correlated to another, when like one increases, the other increases also, right? And so we often talk about this graph of correlations here, whereas one thing increases, another increases, or as one thing increases, another thing decreases. So a correlation can have its correlation coefficient here. Now, usually there's not a direct thing. We have these kind of bubble graphs where we have all these dots. Let me just open this image up. So here we have a bunch of data graphed, and we'll have it maybe it's the size of an apple tree versus how much fruit the apple tree generates. So as the size of the tree gets bigger, the amount of apples we get from it gets bigger also. But that's not always the case, but it tends to go up this way for this. Maybe it's like the opposite. Maybe this is the age of the apple tree and how much apples. And as the apple tree gets older, we get less and less fruit from it for this. And again, sometimes there's a really strong coefficient or a relationship. Sometimes there's a relationship, but it's kind of messy. We can still see it kind of goes up and to the right here or up and to the left, but it's not so clear. Now, correlations, we don't care, how, we just care there's a relationship there. It doesn't measure how much that relationship is. So like here, we see that as, like, let's say this is how tall a tree is and how much fruit it generates here. So if we look at down here, short tree doesn't have very much fruit. Taller tree gets a little more fruit. But again, this line is pretty flat. There's not that much difference compared here, where here a short tree gets very little fruit and a tall tree gets a lot of fruit. But both of these values will have the same correlation coefficient here. And correlation coefficients don't measure a lot of patterns. They only measure what we call correlation. So these are all patterns that aren't measured in our correlation coefficient. So sometimes people will cite that these are correlated here, but you have to realize what that could imply. And then remember, you've heard this phrase, I'm sure, correlation is not causation here, right? There's some fun examples from different places of this sort of stuff. Oh, I just updated that link. What did I do wrong? It wasn't working, and I just updated it. So what did I update it to? Huh. That's really weird. I swear this morning I tried out that link. Okay, well, let's look at this one. Um, so this is our graph that shows that if you eat ice cream, you're more likely to die of a shark attack there, because this just relates uh, ice cream sales to shark attacks by each month here. And in there certain months, as you eat more ice cream, the number of shark attacks also fly. And again, people would then say, well, I won't eat any ice cream, so I'll be safe from sharks. Because but that again, there's a correlation, there's no causation there. That's not going to help you. So this average temperature and SpunSOT stuff works through a different example of correlations and data. So if you're not that familiar with correlations, you might want to read through this one, this show, and it's just, again, you don't have to worry about the Python code this much necessarily, but you can read, you kind of look at the graphs and look at this. This is trying to show some of this relationship between this data. And so see if you find that interesting. If you know something about correlations, you can play this little game. This shows data, and you have to guess the correlation coefficient here based on this. So I would guess, like, this one's obviously negative. This one's, I think this is the strongest correlation here. And I think these are actually swapped, but I'm just gonna guess them this way. So again, I got these two wrong for this. So you'll show you data and you have to guess the correlation coefficient, which I find fun, but maybe you won't. Okay. So if we have data that's correlated, we can use regression to predict this data. This regression has been the standard way. I mean, I used to calculate regressions. This is before we had computers. When we had data here, I would just, I was taught how to calculate regressions and predict values simply by hand there. Now, and again, every spreadsheet, Excel, everyone, any sort of data can generate this prediction, these regression lines. So the idea is if we have the blue dots here, we're going to calculate some prediction line, what's called a regression line here. And again, we're trying to find a line here that minimizes these lines, these distances from the data to the line for us here. And so there's a relatively simple technique to find this line that minimizes this distance here for us to work with. So, and again, nowadays, I don't even remember how to do it by hand. You just always use a computer, a spreadsheet or something like that to do that. So you find that line. Once you have this line, you can ask questions like, oh, okay, if this value is 4 or like 3.5, what should the Y value be? And you can just go up to hit the graph and go over and figure out what value it is for this. So, and you can do this with multiple dimensional data. This is linear regression where you generate a straight line. A straight line. You can do non-linear regressions here. And then again, the idea is to make predictions for this. So if you're looking at this average temperature here, 12, you can say the carbon dioxide parts per million is probably at like 3.72. And I'm just eyeballing it by this line, but linear regression will let you calculate that exactly right. For that. I'll just note that this regression stuff, plotting things online, is different than what is often called time series analysis. Like we're trying to predict a value on the stock market. We'll talk about this later on, and this is a little more complicated We generally are not trying to just draw a line through this trend. We have to worry about other things when we're doing time series analysis. So why don't I have you for the last 20 minutes here, go and try this little POGL activity here. We used to do this and have you turn it in, but we're not gonna, this is just gonna be an optional activity. So again, we're in unit 2. We're under this learning resources correlation stuff. Scroll down to the very bottom here. Don't worry about the worksheet. Again, you don't have to turn anything out. Just go through the notebook and walk through that. It'll have you import some libraries, bring in some data, and display this data. This data is real estate data from California, I want to say. I'm not sure. But we have the price of a house, the number of bedrooms, number of bathrooms, square feet, the size of the lot, like acres, that's actually in square feet, number of floors, if it is on the waterfront, and some other measurements here for every property, like the zip code it's in, and stuff like that. And then we can plot this data here. And then the question is, and we can plot a regression line, the data. And we can actually use linear regression. I mean, you can do this on any spreadsheet, but we're doing it here in Python here. And then we can do some predictions. So this is a house that is 3,000 square feet. It's going to sell for it's estimate that we will sell it for $700,000 for this. My wife loves house prices and is fascinated by that. So she has an app called Zillow. And every time we're driving around, especially if a house is for sale, although you can do it on any house, she'll look at, I wonder how much that house is for sale, especially when we're somewhere that's not in Duluth or somewhere like that. How much does that house cost? And you can bring it up. And Zillow does something, a little more complicated version of this, but something very similar to this, where it will predict a house value here. So again, now you can go through, I can ask you some questions about this here. So one of the questions is, what do you think the correlation coefficient is of this? So look at this data here. Let me zoom out just a little bit. Oops. Here's our data. What do you think the correlation coefficient is of this data? How well correlated is this data for this? And remember that, like, 1 would be it all on a line. 0 would be it's all spread out. 0.4, 0.8. What do you think? What do you think that correlation coefficient is? 3? 0.3, yeah. It's all between 0 and 1. Like 0.3? Yeah. So, yeah, what do you think of that correlation coefficient here? And then can you predict how much a 4,000 square foot house and a 6,000 square foot house would be with this model here? So a couple ways of doing it. Can you just look at this graph here and say, oh, 4,000 square feet would be somewhere in here. Where would that be? Or better yet, you can look at the version with the correlation line here in 4,000. What would that be? So what do you recommend? So that, to me, I think this is in millions over to the left. it looks like it's about not quite a million values. Or again, you can go down to the bottom here and have the model actually tell you exactly, not just looking. If I had 4,000 square feet, million, 450,000 for those. So feel free to play some more with this, especially if you're not that familiar with regression here as we walk through that. And again, you don't have, there's some questions in here you can walk through. We used to do this and have students submit it. But again, in order to make room for some of the more advanced AI, machine learning, prompt engineering, and creating AI agents and that sort of stuff, we're getting rid of this. Well, we're just putting it here quickly. So feel free to go through this. Regression's used is a standard process everywhere, for this sort of stuff. Okay, I'm going to go back here and talk about what we're going to do for the rest of the week. So remember, you have to post discussions, and this week's discussions will be a visualization, a good or a bad visualization. And again, feel free, there's examples with Pinterest, Instagram, and again, Tumblr. So you can use any of the, and again, you can find it anywhere. In fact, I would like to see people find some other data visualization examples here. If your Reddit feed doesn't include r.data is beautiful, you might want to add that to your Reddit feed. So assuming you have a Reddit feed. I have a Reddit feed. You should have a Reddit feed, right? So, okay. So that's this. We'll do the learning notebook with the iris data next on Thursday. We'll walk through that. And that will be similar to the project. For the project, you will do breast cancer data, a little more sophisticated data, and you'll have to set up your own data cleaning and your own data visualizations. But you can use the iris flower data that we do in class as a starting examples for this. Now, for the project, help you kind of get, well, you think this is going to help you. We're going to break you into teams of 2. So we assign you a partner. So hopefully on Thursday, we'll come in here, we'll assign you a partner. We have some new, we'll see, I think, for this. So we'll assign you a partner and you can work with your partner on it. You can decide how you want it. If you're just in class, you can just work what we call synchronous teams, both work together on this, sit side by side and do it. If you're on Zoom, we'll set up workstations or, breakout rooms, and you can do it on Zoom that way. If you're not here on Thursday, especially the online asynchronous students, you have some other options. One way we often call is ping pong, where one person does parts of it and shares it, and the other person will do the other part, and you go back and forth filling it in. Another way is Q&A, where you both work on it separately, but when you get stuck or you need help, you just email your partner or text your partner and ask for help with some things. So you can certainly do that way. This Q&A way often reminds me of this song from the Book of Mormon. I just thought I'd share with you. I don't know, have you heard the You and Me, but mostly me, as far as your group or team projects go? So, yeah. Right. That's okay. So they're assigned to teams. These 2 Mormons are assigned to work together. So I'm going to jump ahead. That line, the Heavenly Father, I've chosen you and me, but mostly me. I just love that as far as projects go. So again, You can decide how you want to work. If you want to be you and me, but mostly you with your teammate, you can do that with this Q&A version. Although I don't think that's the best way. If it were the best way, it wouldn't be a comical song in a musical there. So just so you know. Okay, so that's the project. And remember also, there's an explore activity, a tutorial you have to work on. You have to do one of these tutorials here and fill them out. You should be spending 45 minutes to an hour working on one of these. Okay, so I'm going to wrap up. Feel free to work on any of this for the rest of the class if you want here. Questions on this? All right. Online people, any questions? Staying warm out there? All right. Okay, see you, Alex. I'm going to shut down Zoom then.